Okay, screen is visible, right? No issues. So, yesterday day before yesterday, we start with, I think, uh, first unit wherein we check few points as a revision from your first year syllabus. Now, next is, I think this point is also, just a minute. Okay. So we are talking also about number systems. So many number systems are there. I think four type of number systems we gone through a day before yesterday in first lecture. Now we'll see few conversions. I think conversions झालं होतं का तुम्हाला first year? Binary to decimal, decimal to binary, hex, octal. Yes. Okay. Okay, no issues then. So we'll firstly cover few points with few examples from this conversion, right? So first and foremost conversion is uh, binary to decimal. How to convert this binary to decimal? Yes, tell me a method. Hmm? Put it in chat now. Okay, all ones. Four. Okay, five. This is my binary number. I need to convert this binary into decimal. How to convert? Yes. How to convert this binary number into decimal? Yes, anyone. माझा आवाज पोचतोय ना? Okay. Multiply by 2 raised to n. And that n is, Arti, Saloni is also given the answer that yes, since it is positional weighted method, since it is positional weighted method, we need to consider it, right? So starting from right to this side, right? So this is zeroth position, first, second, third, and fourth. So 1 into 2 raised to 4 plus 1 into 2 raised to 3. Likewise. Okay. So complete this. Hmm. Complete this. Okay. So those who are done with, no, convert this 1, 1, 0, 1, 0, 1. Convert this to decimal. Hmm. Convert this to decimal. 1, 1, 0, 1, 0, 1. See, from here onwards, no, you need to keep notebook with you all the time for this subject, right? Because you have to draw something. Yes, Siddhi. Yes, Siddhi has given the answer is 53, right? Okay. This is 0, 1, 2, 3, 4, 5. Is 4. Yes, the answer is 53. Okay, the answer is 53. Now, how to convert no fractional part? How to convert fractional part? Hmm? How to convert fractional part of binary to decimal? माईक ऑन करून बोला रे. ज्यांना कोणाला बोलायचं माईक ऑन करून बोला. Yes, multiply by 2. So convert this to 110. Yes, this is the binary number. You need to convert to decimal. Hmm. Try out this. Okay, Pallavi. No, no, no. Why is written that multiply? No, you need to check positions, right? Pallavi, you need to check position, right? This is 0, 1, 2. Likewise, no, from this decimal point to right, it is -1. The position is -1, -2, -3, and all, right? So you need to multiply those positions, right? 2 raised to that position. You need to multiply with that digit. Hmm. Tell me the answer. Siddhi, you have given the answer like 27.625. Yes, that answer is correct. Just again type the uh, step before that, right? What all positions are present, right? Which position has which value? Write down that step in chat box. Yes, Siddhi, 3, and Mansi as well. I think, okay. One more important thing is there are two two, three methods available, right? For this conversion, few are multiplying, few are using positional weighted method and all. So for this, no, if you need to decide based on what all marks are there, right? So if you given the example for that, no, you need to show all these steps in that case, right? So you need not to answer directly for that question, right? So you need to show the steps how actually you are going to solve this, right? So for that reason, I think Pallavi earlier said that multiply by two. So in that case also you need to show all the steps, right? Which bit you are taking, how you are multiplying which bit, then added to added into that what we say a result, right? So those all steps need to be shown over here. I'm going to take this by one method called positional weighted, wherein weight is considered. You can directly multiply those binary bits as well. That is, I think, different method. You can learn. You possibly learn this method in first year, I think. Right. So this is about binary to decimal. Sorry, decimal to binary. Okay. Convert this number to binary. How to? Again, it has two, three different methods. Just tell me those methods, how to convert that decimal number into binary. Are you with me, right? Are you listening to me, no? अरे ऐकताय का तुम्ही? Okay, okay. Okay. Tell me how to convert this number to binary. How to convert? Anyone? One way is dividing that number by two, right? And keeping a remainder with this, right? So it is 26, 0, again, 2. Try to divide this and find out the remainder. Hmm, okay, and need to write it in reverse order, right? This is called, you possibly may say, successive division or double method uh, to conversion, right? So you need to divide given decimal number by 2 and keep remainder in that division and write that remainder in reverse order, right? Write that remainder in reverse order. So 110 100 is a binary number which is converted from decimal 52. So this is how you actually convert a decimal number into binary, right? Okay, try this one. I'll give you short, simple example. 13. 13. हम्म? अरे इतका वेळ लागतो का सॉल्व्ह करायला? तिथेच आहे समोर. सॉल्व्ह केलेल्या एक्झाम्पल मधनच तुम्ही फाइंड आउट करू शकता. इतना, I think that could be the answer. 1101, right? That could be the answer. आहेत का तुम्ही? Are you with me? Are you with me? तुम्ही हे बोर होते का तुम्हाला हे? अदरवाइज मग स्किप करूयात हे. जर तुम्हाला येत असेल तर स्किप करूयात. मी पुढचा पॉइंट चालू करतो. वेळ नको जायला. याच्यावर 8 ते 16 मार्काचा प्रश्न विचारला जाणार कन्वर्जन्सवर. तो हे जर तुम्हाला येत असेल आणि तुम्ही बोर होत असाल, मला काही प्रॉब्लेम नाही. आपण स्किप करूया, डायरेक्टली पुढचा पॉइंट स्टार्ट करेन. काय करूया? चालू राहू देत आहे असं की नेक्स्ट पॉइंट स्टार्ट करूया? तुम्ही आन्सर नाही देत पटापट. स्किप करूया का हे? येस नो टाका. थम्स अप काय आहे? Okay. Next is this is my decimal number 0.75. Convert it to binary. How to convert? Hmm? How to convert this number into binary? How to convert that number into binary? 75. Yes, multiply by 2 into 2. That is 1.5. Right, 1.50. So keep this as your binary number first. Then again consider the values, which consider the value after radix or decimal point, and that is 0.50. Right, multiply that again by 2. That is 1.00. Right, so it is 0 now. Put it in this way, right? Sorry. So 11 0.11 is binary number, right? 0.11 is binary number for 0.75. Now I'll give you one example to solve. Okay, 25.5 converted to binary. 25.5 converted to binary. Now there are two parts. One is fractional and another one is wherein for 25 you need to divide, right? And for fractional part you need to multiply, right? It is by 2 only. You need to divide to multiply and keep those answers ready and after and before that radix point or decimal point. Okay, try to solve this. Yes. Okay. So for integer part or complete number, no 25, it is 11001, and for fractional part it is 1 again. So mention like 11001 dot 1, and this is a binary number conversion for this 25.5. So this is about conversion from decimal to binary. Okay, signed binary numbers. Now we are going to talk about signed magnitude representation of binary number. Now, what is that about decimal number? Just tell me about decimal number. What is signed numbers? What all signed numbers are present? How actually those numbers, decimal numbers, are represented if those numbers are signed in case of decimal? Hmm? How those numbers, decimal numbers, are represented if those numbers are signed numbers? Put it in chat. Okay, I'll tell you. For signed decimal, no, decimal numbers. If suppose 7 is my number and nothing is there in front of that, then that 7 number is positive in case of decimal representation. And if that number is negative, then you possibly write a negative sign in front of that number, right? In case of binary, since those binary numbers has only two symbols, and that is 0 and 1. How it is represented? The negative numbers are represented by 0 in case of binary. Sorry. Negative numbers are represented, positive numbers are represented by 0 in case of binary, and negative numbers are represented by 1 in case of binary arithmetic, right? So how it is represented, how it is represented in case of binary? If suppose the number 7 is there, 1 could be the binary number. If 0 is attached in front of that, that means this number is, this number is, yes, this number is positive. Yes. And 1 and 1 is there in front of that number, then it is negative. Now, how to check that first bit? If suppose you have notification that this binary number is signed binary number, then you need to consider MSB, right? A most significant bit should be your signed bit, and other thing you considered as number, or you can say magnitude of that number, right? So in that case, first number should be considered as sign bit, or first bit should be considered as sign bit, and remaining all bits are considered as magnitude of exact number, right? If that representation is signed representation in case of binary, right? So this is about a binary representation, binary signed representation. Now, have you heard about complement representation? One's complement, two's complement. Hmm? Have you heard about one's complement and two's complement representation of binary? Okay. Nines and tens complement for decimal. Nines and tens complement for decimal. Okay. So I'll tell you first about nines complement. Nines complement method. If I need to find out, see, I have a number given there, that is 3465, which is a decimal number, right? Uh, then if you are trying nines complement, you are trying to find out nines complement of given number. In that case, what we need to do here is we need to use this number and need to subtract it from 9. How many digit? That many digit which are present in a number. How many digits are present in that number? Total 4. So 4 nines you need to keep, and then you need to subtract this from 9. What is the answer? Hmm? What is the answer? Hmm. 6, 5, 3, 4. Yes. So this is your ninth complement, right? Ninth complement of 3, 4, 6, 5. How to find out tenth complement then? Just add 1 into this number, right? This is tens complement, right? So this is about ninth and tens complement for decimal numbers. Now we are going to see, uh, two's complement, ones and two's complement method of binary numbers. One's complement and two's complement. Now, what is ones and two's complement is? Just a minute, I need to take one example from book. Mm, 1, 1, 0, 1, 1, 0, 1, 0. See, if this is my binary number, 1, 1, 0, 1, 1, 0, 1, 0, then how to find one's complement, right? So in this one's complement method, no, you need to reverse the bits, right? Whatever bits are present, no, you need to reverse those bits. If one is there, you need to write zero for that, and if zero is there, you need to write one for that, right? So this is called one's complement. You just need to complement the thing, right? Reverse करायचं. आता जे काही one असेल तर zero, zero असेल तर one. Now in this case, if one is there, then you need to write zero. Next digit is one, zero. Next digit is zero. Then write one. Again zero. Again zero. Zero to one. One to zero. Zero to one. Right. So this is a given number, or the number which is there on your screen is one's complement of given number. Right. The number which is present at, this is your stage 2, this is stage 1. At this stage 1 you have given number, then after that at stage 2 you have a complemented number, and this is simply a ones complement. So you need to reverse the number given over there. If bit which is present in that number is 1, you need to convert that into 0, and if 0 is present, you need to convert to 1, and this is simply a one's complement. So how to find out two's complement there? How to find out two's complement there? Exactly same way. Need to add 1 into one's complement. Need to add 1 into one's complement. Why actually we are complementing the things here? Why we are having a two's complement? Just keep in mind that this is how we are actually converting two's complement, right? A number into two's complement number. So given number is there, need to reverse that number or complement that number. Once once a zero, zero, so one करतो, and then we are adding one into that. This is a two's complement number of given number. In that case, why actually we are using two's complement method? This method possibly is used to subtract, right? So why this method is using? By using two's complement method, we are actually using this two's complement method for subtraction, right? In digital logic, no, uh, we are not trying to use a different circuit for this, right? For addition, there is different circuit. For subtraction, there is different digital circuit. By using two's complement method, we can subtract. Now, how to subtract using two's complement method? If suppose, uh, just a minute. Okay. Uh, Keep your eyes on screen. Right. If I have two numbers, 9, and I need to subtract 5 from 9, in that case, uh, this example is of decimal, right? But we are taking this example for how two's complement of where we are actually using two's complement method. Just for sake, I'm taking decimal numbers, right? Just for understanding, right? So for this, in this case, this minus 5 is actually converted into two's complement stage. And then after finding two's complement of this 5, we are actually adding that two's complement into that 9, right? And we'll get a result for that. So the uh, things are different. How arithmetic is there about two's complement, that we'll see later. But time being, keep in mind that this two's complement is actually using for subtracting. And by using adder circuit only, we are subtracting a number, right? So by using two's complement method, we are subtracting number from one number from another, right? So for that reason, two's complement is using. So this is about ones and twos complement. Okay. Uh, Now tell me about a few rules about binary addition and subtraction. Yes, tell me the rules for binary addition, subtraction, multiplication, division. Okay, forget about multiplication and division. We can achieve those multiplication and division by using adder circuit and subtractor circuits. Just tell me the rules for addition and subtraction. Okay, how to add, uh, how how those numbers are added, binary numbers. Tell me a rule for those. Tell me a rule. Okay, I've written something over there on your screen. Just tell me, 0 plus 0 is, in case of binary, 0 plus 0 is, in binary. What rule says? Exactly. 0. 0 plus 1 is 1. 1 plus 0 is 1. 1 plus 1 is 0 with carry. With carry 1, and carry, generated carry is passed to next bit. In case of subtraction, 0 minus 0 is 0, 1 minus 1 is 0. 0, 1 minus 0 is 1, and then 0 minus 1 is 0 minus 1 is, yes, what is the difference? 0 minus 1 is, yes, tell me. 0 minus 1 is 1 with borrow, which we need to pass to next digit, and that is 1. So those are few rules present for addition, right, and subtraction. So 0 plus 0 is 0, 0 plus 1 is 1, 1 plus 0 is 1, 1 plus 1 is 0 with carry, right? And in subtraction, all are there, but for 0 minus 1, the difference is 1 with borrow, right? So these are some rules for binary arithmetic of addition and subtraction. Okay, so this is for addition and subtraction. I'll give you an example. Try to add those numbers. I think four numbers are there. Those are binary numbers. Okay, try to add this and tell me the result. Hmm. Tell me the result. How to add? 1 plus 1 is 0 with carry 1. Again, 1 plus 1 is 0 with carry 1. And 0 plus 1 is 1. Right? So carry is there. Again, 1 plus 1 is 0. Carry 1. 1 plus 1 is 1 plus 1 is 0 with carry, right? So 0 plus 1 is 1. Again, 1 plus 1 is 0 with carry 1, right? So two carries are there. Again, 1 plus 1 is 0, carry 1. Again, 0 plus 1 is 1, right? Sorry. Okay, 1 plus 1 is 0, carry 1. Again, 0 plus 1 is 1, right? 1 plus 1 is 0, carry 1. Again, 0 plus 1 is 1. Then 1 plus 1. Okay, now 1 plus 1 is 0, carry 1. Again, 0 plus 1 is 1. Keep carry as it is, and this is your result of binary addition, right? Likewise, you can add and subtract. Borrow is also treated like carry in case of binary subtraction, right? You need to keep that as borrow for next division. Wherever you feel that 1 plus 1 is 0, then carry is generated. You need to pass that carry to next digit, right? So this is how you can uh, use a binary arithmetic by given, right? Rules are given. Earlier, we talked how addition and subtraction has to be there for binary numbers, and how that rules are applied is given over in this example, right? Try to solve this simple example. Hmm. Try to solve this 1011 minus 0110. Okay, the answer is 0101. Okay, no issues. 1 minus 0 is 1. 1 minus 1 is 0. 0 minus 1 is 1. With borrow, 1 minus 1 is 0. So this is how you can subtract, right? Now next is octal to decimal. Okay. How many symbols are there in octal? How many symbols are there in octal? Yes, 8 symbols from 0 to 7. And for decimal, those are 10 from 0 to 9. Right. So, yes, tell me an example. You need to convert in any example. Uh, just a minute. Okay, so number is given on your screen 4057, and that is octal number. Convert this number to decimal. Okay, try to convert. How we need to convert this? Hmm? Yes, tell me how to convert this. Which formula method? Sejal. Hmm. Yes, positional weighted. So you can multiply given digit by 8 raised to that position. Okay, try to solve this. Position is 0, 1, 2, 3. That is 4 into 8 raised to 3 plus 0 into 8 raised to 2. Likewise, yes, yes. Just try to convert this. Okay. So the answer is 2095. Someone, so many students are given in chat. Right? The answer is 2095. Then now try to convert. Hmm, This is my decimal number. Convert it to octal. This is my decimal number. Convert to octal. Hmm, How to convert decimal number into octal? Yes, tell me. How to convert decimal number into octal? Exactly. Divide by 8. Yes, exactly. Double method. 378 ला 8 ने डिवाइड करायचं. जे काही रिमाइंडर्स आहे ते रिमाइंडर्स तुम्ही लिहून काढा. ट्राय करा. सेजल, सेजल तुझा ऑर्डर चुकली. ऑर्डर चेक कर. जसं बायनरी टू ते कन्वर्जन होते ना, सेम काइंड. एक मिनिट बघू द्या मला. सॉरी, सांगा त्याच्या. Okay, the answer is 572. Yes, the answer is 572. Okay. This is my octal number. Convert to binary. How to convert? Hmm? How to convert to binary? Yes. Convert decimal, then binary. Okay. Other way also, you convert those digits with 3-bit binary and club those all binary numbers together. You will get a binary equivalent for 367. Right? This is 110111. And for 3, you find it out. And club those all numbers. You will get a number, binary number. Right? That is 011110111 binary equivalent for this octal. Right? This is how, yes, this is how you convert to binary. Again, from binary to octal, whatever binary number is given, try to group those number into 3 and find it out a decimal equivalent for that. Right? But for grouping, you need to start from this side. Right? For grouping, you need to start for this side, and then whatever numbers are there, you need to write a decimal equivalent of that, right? And you will get a octal number for that byte, right? So this is how from octal to binary and binary to octal we can convert, right? This is how we can convert. Okay, till then, any problem in